A useful amplifier is the differential amplifier. It's used to measure the difference between two usually small voltages. The two input voltages are measured between the amplifier's input pins and ground. And on the diagrams, if you see, they're labeled V1 and V2. The output voltage is an amplified version of the difference between the two input voltages. In general, if you have two inputs to a linear system, the output is going to be a linear combination of those two inputs. You can see in the block diagram above. An ideal voltage amplifier linear circuit model with two input voltages is shown below it. Like I mentioned in a previous video, you want to use the simplest model that incorporates the effects you care about. So in this model, all input resistances were assumed to be infinite and the output resistance was set to 0. To make a differential amplifier, A2 has to be negative A1. Because of the component variations, this is almost, almost impossible to achieve. You can only get it approximately. If we do or define a differential gain A sub D and a common mode gain A sub Cm, then the output voltage may be expressed as A1 times V1 plus A2 times V2, which is equal to AD times the difference, V1 minus V2, plus ACM times the average voltage, V1 plus V2 over 2. This difference term, V1 minus V2, is called the differential voltage. And the V1 plus V2 over 2, that average voltage, is called the common mode voltage. The differential and common mode gains, that's ACM and AD, or AD and ACM, those are functions of A1 and A2. A measure of how differential an amplifier actually is the common mode rejection ratio, or CMRR. CMRR is defined as the ratio of the absolute values of the differential gain to the common mode gain. The higher the better. A perfect differential amplifier has an infinite common mode rejection ratio because the ACM equals 0.